Okay, sorry. All right, so now we're going to take a segment, like I just said, segment, and go from C to the other side. If you want to make sure that is that point, the intersection, you can do an intersection first, and then do a segment. But I think if you get it close, just make sure it's on the triangle. Okay, so go ahead and put that segment there, and then we can hide those crazy lines on the outside. So go to Edit, Show Hide, and then click the lines. They should fade. Make sure you're clicking outside of the triangle. They should fade, and then go back to the arrow. And there we go. There's our angle bisector. Let's confirm that that truly is the angle bisector. How can I do that? Yeah, let's measure the angle. So go to Measure, choose the first one, and I'm going to select 3 points, okay, just to kind of make sure I get the right angle. So I'm going to go D, C, F on mine, and it tells me that this angle is 42.4. And then I do the other angle, F, C, E. And if they're on top of each other, you can go to your arrow and kind of move it to where you can see it. So mine was an angle bisector. Was yours? Mm-hmm. Both of my angles were 42.4. Wow, that's the same. Yours is a little wider than mine. All right, that's one angle bisector. 2 to go. 1 down, 2 to go. All right, so let's do it again. I'll run through the steps. We go to Construct and then go to Angle Bisector. Yes, ma'am. What'd you do? Yeah, get your arrow and you can kind of drag it and put it. So choose 3 points to make sure. Try again. All right, go to Angle Bisector. Click the 2 sides that you would like to be bisected to create the angle that you'd like to be bisected. Again, we don't want all of these lines on the outside. We don't want all of those. So grab a segment under Lines and highlight it. Go from the vertex to the other side of the triangle. And then we can hide these lines on the outside. So I'm good. I at least maybe want one of your angles to be measured to show that it's a bisector, but if you want to, you can do the others as well.
Wait, why does it say n equals and 0 equals?
Those are Greek letters.
Oh, why?
They measured them in Greek, like just to use angle measurements. They use Greek letters. No, it's okay. Don't matter. So mine this time were 31.1 for both. All right, I've got 2 down, 1 to go. Angle bisector. Choose the 2 sides that create my last angle. Use a segment to highlight from E to H. Yep, so many lines. When you turn on your show hide, there should be lines all over the place. I'm glad they had that show hide option. Here we go. And since I measured 2, I might as well go ahead and measure the 3rd vertex too. not wanting to do what?
Oh, do you want to?
What's it? Wants to do it. What are you saying it?
I'm in it.
No, I literally just saw her. Did you mind or did you read? I did.
Alright, so you move it around and see what's going on with it. Make sure everything's good. And we're ready to label that point of concurrency there. So this time we need to intersect. Let's just hit the intersect button right here beside the underneath points. And click 2 of our angle bisectors. It doesn't matter which 2. So if you looked on Canvas, it's already there. This is called, click it, then click the AA, and you can label it Incenter. Incenter. So click the, after you make a point there at the intersection, click it, hit the AA, and Incenter. Very good. Alright, move your triangle around. Does the Incenter go outside of the triangle, or does it always stay inside?
AA and change it to what? Intercenter?
Incenter, yeah. So I'm hearing always inside. Is that work? Is that true for everybody? Very good. So Incenter always stays inside the triangle. It never goes outside. So which other one? There's one other one that we've done where it always stays inside. Which one was that? The first one, yep, which was the centroid. Very good. So the centroid and the incenter always are inside of the triangle. The orthocenter and circumcenter always stay, or can go outside of the triangle. All right, so let's add all that to our notes. Ready?
Ready.
All right. First of all, let's define incenter. The intersection of the angle bisectors of a triangle. The incenter always stays inside the triangle. All right, and just like all the other ones, there's that one extra thing that's special about the incenter. Okay, so let's figure that out.
There it is.
Parker.
Good thing classes are going on.
Hi.
Yeah, no, we're not doing this right now.
Well, they want you in the counseling suite, so don't get settled.
Oh, cool. Okay. Wait, where we gotta go?
The counseling center downstairs.
Smile, big
Smile.
Oh, bless them.
That's 4 years.
He's so
Yes,
funny.
baby.
He does have faces. That was like a really big chip.
Oh. Way to embarrass them, my goodness. Alright, so do you know how the circumcenter was equidistant from all of the vertices?
Sure.
The incenter is equidistant from something, but it's not the vertices.
The midpoints, I don't know. The bisectors. I don't know.
The incenter is equidistant to the side.
That's what I meant.
Oh, okay, yeah. It's equidistant from the sides. So I want to put that in my triangle. So how can I make this to where it's equidistant to the sides?
Bless you.
Like how can I draw that? So like what can I do to show that it's equidistant to the sides? Okay. So maybe I need a line and I can put a measurement on each of those. Maybe a dotted line like we did before. Okay, how do I construct that line? Can I just use this one right here that's already there? Are y'all listening?
Heck yeah, I am.
Can I show the distance from this to this and just use this?
No. I don't know. Let's
See,
see.
you're in uncertainty.
Let's
Okay.
see.
What I'm trying to ask you is, I want to show the distance from this to the side.
There are two different distances.
But if I wanted to measure, for instance, the distance or the height of Kendall, do I take a measuring tape and go like this? All right, Kendall, stand right there. Let me measure you. Let me measure how tall you are. Let me measure your. No, what do? I go straight, right? Straight. I don't say like this. I say like this, right?
What's wrong with doing
Y'all see what I'm saying?
Yeah.
See where I'm going with this? So can I use this? Why not?
Not straight.
Yes, very good. Not straight. I need to go straight to the side. From the in-center straight to the side. So what do I need to do since I need this to go straight to the side? Very good. I need to make sure it's perpendicular to that side. Does that look like it's perpendicular to that side? No. So how do I do that? How can I make it perpendicular? Yes, use the perpendicular line tool, which is under construct, and it's the second one. So again, we're gonna have to do some hiding and some stuff, so hang in there. All right, choose the perpendicular line icon, and then choose the in-center and then a side,
Any side?
any side.
Got it. Should we make it dotted? Or like...
Good. So I only care about this part of the segment because that goes from the in-center to the side that I chose. So I'm going to put a segment right here. I'm going to put a segment right here, then I'm going to hide this line, and I'm going to make that segment dotted or colored or whatever you would like.
Blue.
So what I just said, I'm going to take a segment from the in-center just to the side of the triangle that I chose. That's perpendicular. Then I'm going to hide that line.
Whoa.
I know, so many lines. And then I'm going to make that line dotted or colored or whatever.
Shut up. Girl, me too. You're so mean.
A lot better than doing it by hand with protractors and rulers, I promise.
About myself.
All right, that's one. Let's do the rest. If you didn't catch it the first time, here I go. I'm going again. You go to construct and choose perpendicular line. Then you choose in-center and a side. It does one of your two remaining. So I chose that top side right there. All right, so I only care about showing the distance from the in-center to the side of the triangle. So I'm going to overlap it with a segment from the in-center to the side of the triangle. Now I can hide that segment. Look at all those lines. Hide that segment and then go back and click it and make it dotted. Okay. Okay. I'll be back there in just a second. Okay, I'll be back there in just a second. Let me finish this up. If yours is not working, watch one more time. I'm going to do it one more time. Make sure you're following the exact same steps as mine, okay? So, I'm choosing perpendicular line. I'm choosing in-center. And then my third side that I haven't used yet. I'm going to move mine around so I can see it a little bit better. There we go. Okay, so there's my perpendicular line right here. I only care about from the in-center to the side. So I'm going to put a segment there. So in-center to the side. So when I put that segment there, I'm able to go and hide that line. Then I want to go click on that line and make it dotted. Okay. So let's prove that those are actually equidistant. So the in-center must make sure it's equidistant to all the sides. So let's go to our measure tool, the centimeter with the arrow, and click each of those.
Are we supposed to measure it? Oh, yeah.
So all of mine were 3.6. Did all yours match?
Yeah.
No.
Where?
How close?
No, mine don't match.
How
Wait,
close?
one doesn't match.
Okay, move it around and just see what happens.
Wait, did I do it right?
Is it still a little bit off? It'll be okay. If it's just a little bit off, it'll be alright. Don't sweat it. Yep.
I think I did something. That one is like 0.7.
They're not
I clicked it. Was I supposed to? Oh, I probably took away the wrong part.
Maybe, yeah.
Nards, you gotta be kidding me.
Yep. All right. So let's add our last little notes here. Our last little note, and that last little note should say, the in-center is what? Good. Use our fancy word, equidistant from the sides of the triangle.